It looks like the audio got cut off at the end of that last video, so I'm just going to talk you through example 5 one more time. So we have our position of negative 16t squared plus v naught t plus s naught. Now note that we are given an initial velocity of 60 feet per second, and we are also given an initial position. So our position equation at this point is s equals negative 16t squared plus 60t plus 6. And we need to figure out how high this ball is going to go. And so this is a height or a position equation. And you could see even if we plugged in 0 for t at time 0, the height or the position is 6. And we need to know how high does this object go. And so if we just think about this position time graph for a second, that's going to help us out. So if this is time and this is my position or my height, this is a negative quadratic. And so a negative quadratic is going to look something like this. And this is not the actual path of the object. The ball is not necessarily following this path, but it shows the position over time. And you can see that the highest position is going to happen at this time right here. Well, we can figure out what time this is because we know that the rate of change of the position function at that time is 0. Or in other words, the velocity of the ball is going to be 0 when it changes from going up to going down. And again, this is not the path of the ball, but we could see that if the position is going up, then as time increases, then the object's still going into the air, and as the position starts going down, then the object starts falling. So we need to know the velocity, or we need to know when the velocity is equal to 0, and that's when we're going to get this. So just a reminder, when an object's going into the air, it's going to have a positive velocity, and you can see that in this picture. And when the object is going down, it's going to have a negative velocity. And again, you can see that in the picture. So we need to see not when the velocity is positive or negative, we want to see when is that velocity, the rate of change of that position function, equal to 0. So my velocity equation is negative 32t plus 60. It's the derivative of s, or you could go back to this, it's the antiderivative of v. Or I'm sorry, the antiderivative of a. So when is this velocity equal to 0? That's what we are finding here. So take this equation, solve for t, and we get t is equal to 60 divided by 32, as you see here, is 1.875. And we just take that time and substitute that time back into the position equation. And so you can see that I've done this over here in the calculator. I've done negative 16 times 1.875, or my answer squared, plus 60 times my answer plus 6. Leads me to a value of 62.25 feet. And so my answer to this question is C. So hopefully these examples help. And I just want to emphasize one more time, I think the most important part of a lot of these examples is apply the simple power rule as much as you can, or apply, your knowledge of derivatives as much as you can. And we did that in the beginning of this problem when we had v equals negative 32t, and I went to do an antiderivative of that. I left the negative 32 there. Then I did the antiderivative of t to get t squared over 2. So I'm always trying to make my antiderivatives as easy as possible. And so don't involve those constants in your thought process. Leave those out in front and then do the power rule for antiderivatives as you've seen me do in these practice problems. Okay, so hopefully you can tackle that homework now.